Alright, I was told that they saved the best for last, so you guys are in for a treat here. This is going to tie in really well with what Q was talking about and what Greg was talking about. Specifically, this is going to be an interesting phenomenon that was touched in both those presentations. What it is when different attacker groups compromise a resource and they start battling each other for control of that resource. So we see this happen quite a bit in the cloud. We've seen a big uptick of this over the last year. And generally this happens with cryptocurrency mining. So you find a way into a server in the cloud, and then you try and figure out who else is there and get rid of them if you can, and then start mining from there. Alright, just a quick background on myself. My name is James Condon. I'm Director of Research at a company called Lacework. Lacework is a startup out of Mountain View, California. And we do cloud security, so we do everything from configuration and compliance auditing for AWS, GCP, and Azure, all the way down to Linux, containers, and Kubernetes runtime security. So we cover quite a wide area there. How I got into InfoSec, I started out in government, working for the Air Force, doing computer crime investigations. Following that, I worked for Mandiant for a few years. I was a network traffic analyst doing incident response and threat intelligence. And then I worked for a company out here, ProtectWise. I built out their research team, investigated threats, focused on the network side of the house. So primarily, I've been doing network forensics, incident response, a little bit of threat intelligence, and most recently, cloud security. So if you're interested in any cloud security topics, please be sure to follow me on Twitter. Feel free to email me at any time. You can also check out our blog. So one of the things I wanted to do here, since we have a small enough group, is we're going to run through some various case studies of different malware families and the tactics that they're using to get rid of other pieces of malware on a given host. So I want to encourage discussion around these, so I'll probably throw up a few questions so we can kind of drive this conversation and go based on some of the feedback from the audience. So how I kind of got into this. I originally, like I was saying before, worked with traditional enterprise security, doing a lot of APT type research. So about a year ago, I started shifting my focus in the cloud security area. As I started getting an idea of what was going on in the cloud, doing some research, what type of threat actor groups are operating, one of the big things that kind of sticks out is things like that Palo Alto reported XBash. And a few years ago, ransomware was a really large issue when it came to cloud workloads. But then we kind of see this shift most recently, and this has been a shift to cryptocurrency mining, specifically Monero. And what I kind of did is when I first started getting into this is, first step is let's deploy some honeypots and see what's going on. So I'm pretty used to seeing with any open application exposed to the internet, you're going to get all kinds of different exploits thrown at it, nothing new there. But the thing that surprised me a little bit is once we started getting these honeypots compromised, is we would start seeing installers scanning for other processes, looking for IP addresses to sinkhole, and take out other people that might take care of one of these servers. So in particular, one of the first honeypots we set up, it kind of shifted hands about 4 times every 4 hours. And a lot of this was automated by botnets, kind of kicking each other out, starting over. And that really kind of fascinated me, so I really wanted to dive into some of those bits and pieces. So one of the first places to start, really good idea, if you want to get something compromised as quickly as possible, is Redis is a great place to go. It's really easy to set up a Redis honeypot. So we intentionally picked something pretty old. We just used Ubuntu 14.04, use apt-get install Redis server. And this actually installs like a really old version of Redis 2.8.4. This is vulnerable to CVEs from 2015, some nasty remote code exploitation vulnerabilities. And then what you want to do is just give external access to this host. So opening up port 6379. So if you haven't seen what network traffic for Redis looks like, and to back up just one step, Redis out of the box isn't going to have default authentication and authorization. It's also not going to have default encryption. It's not going to be using TLS by default. It's not going to be using encryption at rest. So out of the box, this is pretty easy to use for Honeypot, but can get in really sticky situations if you're using it for other reasons. But what we have here is this is just a Wireshark screenshot, and the protocol that it uses is called Redis Serialization Protocol. And as you can see, this is easy to digest. It's just clear text protocol where you're just feeding commands, and there's some numbers that will come through with the length of the command and the command argument spot and things like that. So one of the things that we see first and foremost is people interrogating the server, getting some more information about what it is. One of the common attacks that we would see is they would set key value pair, in this case it's weapon X, weapon Z, and these are cron job entries. And so this is common mode of persistence with a lot of these cloud attacks, is setting a cron job to continually pull down a bash script and execute it. Sometimes that's from pastebin, sometimes it's from other places, but a lot of times those scripts will get continually updated, so they can, give new commands to the botnet and things like that. In this particular case, just based on how we set up the honeypot, these end up failing. They're trying to eventually write these keys to the cron job files. Another attack that was pretty common that we saw is trying to get SSH access. So in this screenshot here, trying to take an SSH key and ultimately get that put in the root.ssh directory. Again, in this case, no luck. So then next, we end up seeing some successful exploit activity. So this is a Lua vulnerability. This is actually CD 2015 for 335. And like what Q's saying is there's a lot of outdated applications. So this occurred within one of the first days, so you know that people are out there running really old versions of Redis that are vulnerable to this. And what ends up happening is after the exploit is we just have a command to download a bash script and execute it. So it's a curl command, and here they're using the service called ngrok. Has anyone heard of ngrok before? Yeah, so ngrok it's a simple service that you can use you can basically take like your laptop, put a web server on it, and you're behind a NAT, and then you can expose that and then have it internet accessible from a domain of choice. So in this case, we saw this actor group using ngrok to serve up this first bash script. And this installation script has a number of different steps. It's not super long, but most of the steps include downloading a different downloader, maybe downloading different pieces of malware, maybe trying to put in an SSH key for persistence, maybe setting up a service, things like that. And this was last year, about October, and I came across this section of code, which I found pretty interesting. And what we have here is we're looking for process IDs associated with certain keywords, and then we want to kill those processes. And if we take even a closer look at it, and it's really interesting, you'll see different attacker groups do different approaches for how they format some of these different queries. But essentially what we're doing is we're just setting this PID variable, and then we're doing a process listing. We're grepping out the grep process. We're looking for XMR stack, and then we're getting the process ID using op. Make sure that we got a process ID, and then use kill-9. So this will run through, and if there's a cron job for this going on, every time the script gets downloaded, this will get rerun. So if any of those processes pop back up, those might get taken care of. So real quick, has anyone seen this type of activity before, maybe in data centers that you're protecting? Okay, we know for sure. Does anyone want to tell us about an instance where they've seen this? Maybe the application that you saw exploited? Get extra credit if you know any of the answers. Okay, let's take a look at how this process is killed. Can anyone think of the advantages and disadvantages of this tactic? The tactic being scan active process listings and kill them. Say you're a bad guy and you want to make sure other crypto miners aren't running on this system. Is this an effective tactic? Yeah.
Sure, because if you have multiple processors that crypto mining uses CPU, the more CPU crypto processing you have running, the less chance you actually have running propagation.
Yep. Yeah, definitely. So I find this to be really effective. Can anyone think of maybe an issue with just killing the process? Just common? Yeah. Yeah, so depending on the user that you're running and your visibility into which processes are going, you might have some reduced visibility there. If you're doing it from userland, maybe there's rootkits involved and you can't see which process is running. Another thing is basic persistence. So if you're not continually scanning and killing these processes, you might run into some issues with them popping back up. But this is kind of one of the most common methods that we see. So fast forward to March of this year, there was a nasty CVE that came out for Confluence. This was CVE 2019-3396. And so this was a remote code exploitation. This was done pre-authentication. So we expect Confluence servers to possibly be internet facing. It's not best practices. But right after this came out, people went on Shodan and they're like, yeah, there's like at least 20,000 different Confluence servers facing the internet. Can't necessarily see which versions they are, but it's a big footprint. This RCE occurs before any authentication that's necessary. There's also a directory traversal that can occur as well. And the thing that we found interesting with this is you just exploit it with a well-crafted post request. And the first public POC came out about April 4th, and this just appeared on a GitHub. There wasn't much news about it, but what we ended up seeing in our data set is around April 8th, the POC was being actively used in some different activities. Then on April 10th, there was a detailed write-up of this particular POC, and then that kind of opened the floodgates, and then there was like a massive amount of attacks going on. So here's just what this looks like from a network point of view. We have a post request going to our Confluence server. And in this payload, the actual exploit ends up occurring in this velocity template, so you have to serve it from somewhere else. There's a number of different POCs out there. Some of them get the HTTP version to work. Some of them use FTP. But one of the things that was really interesting in this particular one that we caught is we actually see them using the exploit to run a command to look for this DB launch as process to kill. Now, this is a common malware name that we've seen with some of the crypto mining activity. So in this case, it's particularly fascinating to see the attackers just doing mass scanning to try and kill from outside the box. And so this is one of the install scripts that we pulled down, and as you can see, this ends up getting pretty big. I'm actually just going to show you real quick what this particular one looks like. So we have a bash script, and the vast majority of this bash script is done for killing different processes going on. And some of it's kind of funny, and it really makes you wonder like who's behind this and the inconsistencies that occur as we go. So we first start off with this for loop that's just iterating around and making sure that pkill's not running and that sleep's not running. And I don't know, maybe they weren't confident that this was going to work all the time, so maybe that's why it's iterated so many times. And shortly later, or right following it, sleep's targeted again. So seeing this occurring multiple times. There's the Kerberod's downloader that was talked about with Rock. And what we end up getting is we start getting some interesting intel, like, as an analyst, okay, who are these guys targeting? What processes are they going after? And as we go through it, we've talked about process scanning to kill. What we end up seeing a little bit later is a new simple technique, a little bit different, is actually looking for certain files to remove. And then what we see after this is we actually have a netstat statement. So what netstat is doing here is it's looking for any established connections to these following IP addresses. If they're established, get a process ID and go ahead and kill that. This only works, I'm not sure what all Linux systems that this will work on, this netstat to get that process ID doesn't always work, so that one was kind of interesting to me. But if we take a closer look at what some of these IP addresses are, we see that this 37.59, both of those actually resolve to a very popular XMR mining pool, and that's pool.minexmr.com, so that makes sense. This next one, 192.99, that's a custom Monero mining pool that's been reported using by the 8220 gang before. Next up, this 158.69, another private pool used in association with the 8220 gang. And then this kind of goes on and on, the 192.99, 142. That was seen in attacks that were specifically targeting open Docker APIs and pushing malicious containers to do cryptocurrency mining. And then this 202 one, we saw this as a custom one that was seen in some Kubernetes attacks that we've kind of reported on and talked about. And then, a year or so prior, used in Hadoop and Yarn attacks. So these actors know different C2s that are being used by different groups. They know popular mining pools, and they're using those to try and sinkhole that activity. Another tactic that we see, in this case, that attacker is listing out process listings, ignoring the ones that they're interested in, and then they're looking for any CPU that's running over 30%. And if we have CPU that's running over 30%, we're going to go ahead and kill that. So kind of my impression when I first was seeing this with the Confluence was this here, because we could see at least like 2 or 3 different groups, like within 3 or 4 days of a public POC being used, and they're just kind of doing anything that they can. And if you look at these machines, like the CPUs going out of control, some of them are just kind of shutting down. None of these guys can really get in the money because everyone's going after it. So what I wanted to ask is, when we look at that laundry list of processes to kill and these IP addresses, does that, like, as a blue team person, does that remind you of anything? Any way we do stuff? Because to me, it reminds me of kind of how we use threat intelligence to keep the bad guys out ourselves. We're looking for file names. We're looking for certain process names. We're looking for IP addresses. So these guys are really kind of doing the same thing, but it's more like an illegal capture the flag type situation. What do you think about using netstat to kill processes as opposed to process names? Any thoughts on that? How that may be better or worse?
Process name.
Yeah, process names are easy to change. Another thing that we've noticed is the C2 infrastructure in the mining pools that these guys use don't change too often. So sometimes those IP addresses, end up working out pretty good. Another thing I kind of noted is any of the popular mining pools, a lot of the cyber criminals aren't using, like minexmr.com. What do you think about the killing a process based on how much resources it's using? Is that an effective tactic to take out other competing processes? Can you think of anything that might go wrong there? What's that? Yeah, maybe crash the system, take out something that you need to keep the system running. There's definitely some things that could end up happening. Okay, so this is the third case study. This one's really interesting. This was a great blog post put out by Indozer. They had a talk earlier today. And the author is doing some malware analysis on a piece of malware associated with the Apache group. And one of the big things that they noted is there's several protections and mechanisms in it targeting raw. So this time, one of the big things that we see is that instead of using a bash script to do the removal of files and things like that, the actual piece of malware is looking for the files and it's doing its own process blacklisting. Here we see Kerberod's again, so it's pretty infamous at this point. And they're looking for it in multiple different places. We've seen it, stored in /temp. We've seen it in user bin. It kind of pops up in a different place here or there. But this was a pretty interesting tactic, and I hadn't seen this one before. So this is kind of like our netstat tactic, only I think it's a little bit more effective. And what they end up doing is they have a list of blacklisted IP addresses, and they decode those IP addresses out, and then they add it to the system's routing table using IO control. And they scope it to the local host. So if any connection is attempted to be made to any of these IPs, that's just going to end up redirecting back to the local host, effectively sinkholing it. So outside of this, has anyone, Kira, have you ran into that at all, using IP tables or anything like that?
I'm sorry.
Oh, just sinkholing IPs. Has anybody seen them do it that way in anything that they've run in? Because I've only kind of really seen this specific technique used in that blog. All right, we'll move on to our last case study here. And what this is CryptoSync. Anyone hear of this before? CryptoSync is reported by F5 earlier in March. And CryptoSync is pretty interesting because it carries a number of different functionalities that we didn't see with other malware families. We do see that we have an exploit here, and the payload is to use a bash script to start the initial install. One of the things that's kind of cool about this one, if you're a reverser, is a lot of symbols are left in the binary. So specifically, we have this function call that's search and kill ZigW. We also see search and kill miners. And then we have stop communication of other miner by sinkholing. This one's like pretty verbose here. They even give how they're going to do it. So this ends up being pretty interesting. This has multiple persistence mechanisms, adding an SSH key, adding a service, adding cron jobs for the install script, and then a unique one that we'll show here at the end. But what they end up doing is they take a list of these popular mining sites, and then they redirect them to localhost using the etc host file. One of the kind of disadvantages to this is a lot of the different campaigns that we see are using custom miners, like custom IP address mining pools, and so we don't actually see them using a lot of these popular ones. So I don't know how effective that will be, but this is kind of cool. What they ended up doing is they got rid of the RM binary on Linux, and they replaced it with their own. And so it eventually calls RM, which has been renamed to RMM. But what it does is it checks to make sure that it's persistent whenever it's run. So if we fast forward, or if we rewind back to that one script that we saw, we have a bash script, and it's using RM to delete files. So if it were to delete any of the files associated with this guy, then it would double check that persistence mechanisms are still in place, and effectively make sure that it still stays installed. Okay, did anyone have any other ideas on that? Any tactics that the attackers that weren't presented here that you might do as an attacker? One of the big ones that kind of sticks out in the top of my mind that I've never seen, and let me know if you have, but I've never seen an attempt to patch an application that was exploited to keep others out. You know, there's going to be some pros and cons to that. You might have more of a footprint, you might cause much more noise, but you're already pretty noisy anyway. I think that would probably be an interesting one to see. So if you ever see anything like that, be sure to let me know. So some of the common tactics that we see used: scanning process listings for keywords, scan process listings for CPU usage, searching for known files, established connections, syncalling IPs, and then syncalling DNS. So what this all kind of ends up wrapping back up into is these are all kind of tactics that we can use on Blue Team to gather intel. And you know, you can easily go on VirusTotal to find these installers and monitor for those and look for maybe, you know, new file names, new things to kind of keep on top of, since a lot of this activity is automated. So what I'll do is on our blog, I'll post these slides so you can have them, and this has a number of different resources that dive a little bit deeper into it. But you can go ahead and contact me via any of these methods. Be sure to check out our blog. And then any last questions before we wrap up? Nope? All right, cool. Thanks, everyone.